Hello everyone, my name is Shubhangi Sanjay Jadhav. Today's topic name is bomb calorimeter. Determination of a calorific value by bomb calorimeter. The gas calorific value of a solid fuel and non-volatile liquid fuels can be determined by bomb calorimeter. Principle of a bomb calorimeter. A known weight of a solid liquid fuel is burnt is the presence of excess oxygen is the closed pot and the product of a combustion are cooled to get HCV of the fuel. Construction of a bomb calorimeter. A bomb calorimeter consists of a first one is a bomb pot. It is cylindrical, strong stainless steel pot having a lid. The lid can be fitted airtight to bomb pot by screwing. There are two electrodes fitting through the lid and there is an oxygen inlet value. It is center. One of the electrode is provided with a ring to hold the circle containing fuel. There is a thin magnesium fuse wire tied to electrodes in loop form and the loop touches the fuel. The weight fuel is burned in the bomb pot in the presence of high pressure oxygen. Second is the calorimeter. There is a copper calorimeter in which the bomb pot is kept. It contains a known amount of water and the water is kept circulating around the bomb pot with the help of stir. A Beckman thermometer is kept in the water of a calorimeter, which can record the rise in a temperature of water due to absorbing heat generated in burning of a fuel in a bomb pot. Third is a water and air jacket. The calorimeter is surrounded by air jacket and water jacket to avoid heat losses due to radiation. Next is the working of a bomb calorimeter. First one is the weight, the plate of a solid fuel or a liquid capsule and keep it in the crucible. Keep the crucible in the ring of the electrode. Tie the Mg fuse wire between electrodes such that it touches of two fuels. Second, add about 10 ml of a distilled water and the bottom of a bomb pot and fix the lid tightly of a bomb by screwing. Third one is to fill the bomb with oxygen at the pressure about 25 kg per centimeter square. Fourth one is to place the bomb in calorimeter. Add known amount of water in the calorimeter so that the bomb gets immersed in the water. Fifth one is place the calorimeter in the water jacket over the plastic struts. Keep the thermometer and stir in the water of a calorimeter. Sixth one, put the plastic over on the top and make electrical connection from battery or two electrodes. Seventh is operate the stir for 5 minutes and note the initial temperature of water. Seventh is pass the current for about 5 to 10 seconds to heat the wire so that the fuel catches fire. If the fuel contains S and N elements, they get converted to SO3 and N2O5. These gases get dissolved in the distilled water in bomb to form H2SO4 and HNO3. Second one, note the maximum temperature reached. After that, note the average rate of fall of a temperature per minute and the time taken for reaching to initialize temperature. Last one is open the bomb top pot and wash the content at its bottom into a beaker to find out the amount of S2, SO4 and HNO3 form. This diagram is bomb calorimeter. Calculation. Let mass of a fuel in gram meter equals to mgm. Mass of a water in calorimeter equals to w. Water equivalent of a calorimeter set equals to w. Gross calorific value of a fuel equals to q calories. Rise in the temperature of water equals to T2 minus T1. Heat liberated by burning fuel equals to heat absorbed by water and calorimeter. Therefore, MQ equals to capital W plus W into T2 minus T1. Therefore, GCV equals to Q equals to capital W plus W into T2 minus T1 upon ml. Unit is calorie per gram meter. NCV for the fuel is calculated as below. Of H is percentage of hydrogen in the fuel, then the heat taken by water formed during combustion to convert into steam is equals to 0.09 into H into 587 calorie per gram meter, and NCV equals to GCV minus 0.09 into H into 587 calorie per gram. Correction in a formula. To get more accurate result, the following correction should be considered. First one, fuse wire correction means T1. Out of the total heat obtained, little heat is given out by fuse wire when the current is passed for 5 to 10 seconds to start the combustion. Hence, it must be subtracted. Second, acid correction means TA. This S and N in the fuel are oxidized to H2SO4 and HNO3. Formation of H2SO4 and HNO3 are exothermic, and the heat measured include a small share by this acid formation. S plus O2, it gives SO2. It gives O2 heated, SO3, S2O heated, it gives H2SO4. Delta H equals to minus 144 kilocalorie per molecule. N plus O2, it gives NO3. It gives heated O2 H2O NO3. Delta H equals to minus 57 kilocalorie per mole. Acid correction must be subtracted. Third one is a cooling correction means TC. Cooling correction to be added to rise in temperature, say TC. The accurate formula with correction for GCV is Q equals to capital W plus W into T2 minus T1 plus TC minus TA plus TF upon M. Unit is calorie per gram. This is numerical for bomb calorimeter. Numerical question. Calculation GCV of a liquid fuel if the data in bomb calorimeter experiment is mass of a liquid fuel burnout is equals to 1.025 gram. Rise in the temperature of water 3.04 degrees Celsius. Mass of water in calorimeter equals to 90.00 gram. Water equivalent of calorimeter equals to 770 gram. Cooling correction equals to 0.7 degrees Celsius. Acid correction equals to 43.9 calories. Fuse wire correction equals to 12.8 calorie. Percentage of hydrogen equals to 5. Latent heat of steam equals to 587 kilocalorie per kilogram. Solution this one. Thank you.